Okay, the pink one, a lot of you guys will make algebra mistakes on. So pay close attention and please, please, please ask questions if I lose you. Now, it wants you to say whether or not f is concaving up or down. So we need a sine line graph for f double prime. So we got to first find f double prime. Let's find f prime. F prime, oh shoot, you know what we have to do here? We're going to have to use the quotient rule. Everybody say, oh man. So we have x plus 5 raised to the 1/3. Okay, I don't want to use the root. Okay, so now what is the derivative of the numerator? 0. So it's 0 minus, okay, almost done. Okay, now I have negative 8, 1, negative 81. Oops, I want to make sure I can see that negative. Negative 81, and then I have to take the derivative of the denominator. Okay, now you would have to use a chain rule because it has the exponent, but it's almost insignificant because what's the derivative of the inside?
Oh, no.
Okay, so I drop the 1/3 in front, and I get x plus 5. And then what do I have to do with this 1/3? I'm supposed to take away 1. Now, that's kind of nice. It's just 1. So what is 1 with a denominator of 3? 3 over 3. So what is 1 minus 3 over 3? It is negative 2 over 3. Okay, you still with me? Still cracking? Oh, I forgot my 1/3. Let's throw my 1/3 right here. Okay. All right. So then I take the bottom, the denominator, or this one right here, and I square it. Now, if I square this, dude, do you guys know what you do with the exponents? You know what you do with this exponent and this exponent? If you square it, you multiply. You guys remember that stuff? What is 1/3 times 2? 2/3. All right, let's simplify a little bit. All right, I don't want those negatives anymore. A negative times a negative is a positive. And what is 81 times 1/3? That is 27. And we have this guy. Now, that guy right there has the same base as this guy right here. They have the same bases. And so that means there's going to be some cool simplification that can happen. So I have this one that's on the bottom already, x plus 5 raised to the 2/3. Now I have another x plus 5 raised to the 2/3. Why the heck would I move it down like that? Because we have a negative exponent. If you have a negative exponent, you could drop the base and the exponent becomes positive. So if you multiply two bases that have, or two exponents that have the same bases, what do you get to do with those exponents? You get to add those foos. Add those foos, Mr. Pates. All right, here we go. That is f prime. All right, you still good? We don't need f prime, though. We need f double prime. All right, boo. That means we have to do this one more time. Okay. What's the derivative of 27? 0. 0 times the bottom is going to be 0, so I'm not going to write anything else for that. Next, I'm going to write 27 times the derivative of the denominator. We have to do this all again? Yeah, we got to do this all again. Okay, so the derivative of this guy is going to be 2/3 out in front. And then I take 1 away from the exponent of the x plus 5. When I take 1 away from 2/3, I get negative 1/3. Because you're subtracting, I'm subtracting 3 over 3. All right, I think you guys are hanging. I don't know though, because nobody's saying anything. It's like you did, because it's a cloudy day and this is Southern California and you guys don't like cloudy days. All right, now we have to square the denominator. Okay, so that means I have to multiply the 2/3 by 2. So I get 4 over 3. Nope, you guys didn't catch my mistake, did you? You didn't. All right, there's lots of mistakes here. I need to fix it. Got to go back now because you guys didn't catch my mistake. What is this exponent supposed to be? 4 over 3. My goodness, guys. 2/3 plus 2/3 is not 2/3. Where you at? Where you at, huh? Not with you, Mr. Patey. Forget you. I'm doing my own work. Oh, okay. Fine. 4 over 3. Okay, so now that changes. Oh, man, that changes this guy too. Oh, it changes all my stuff. 4 over 3 And then this is going to be a 1/3. Ooh, it's a positive 1/3 now. Ooh. Okay, if I multiply 4 over 3 times 2, I get 8 over 3 because quotient rule says I have to multiply the denominator. I'm sorry, square the denominator. All right, now I have a 27 that cancels out with that 3. That 27 becomes a 9. That negative 9 is multiplying to the 4 to give me a negative 36. And then I'm going to move this guy to the bottom. What happens to the exponent when I move it to the bottom? It becomes negative. And then I have to subtract the 8 over 3 with the 1/3. And then I get 7 over 3, x plus 5. Woo, woo, that was a lot. There's f double prime for you, Stews. Wow. Okay, now what was the question? Where is f concave up? So I must find possible inflection points. So let's find our possible inflection points. In order to find our possible inflection points, what you do is you take this guy and you set it equal to 0. And when I do that, the denominator is insignificant, and I see that negative 36 equals 0. Well, that's not true. Negative 36 doesn't equal 0, so that doesn't work. Now I need to see where this does not exist. To find out where this does not exist, I take the denominator and set it equal to 0. And what I get is a negative 5. A negative 5. If I get a negative 5, it makes the denominator 0. That doesn't work. You can't have a 0 on the denominator of a fraction. So now I must see, do I have a negative or positive before negative 5? And do I have a negative or positive after negative 5? And I'm going to choose negative 6 and 0 to test. So let's go. What's negative 6? When I plug negative 6 into this, I will get negative 1. Negative 1 raised to the 7th power, which would still be negative 1. And then the third root of that is still negative 1. So I have a negative divided by negative, which is a positive. Now let's do 0. If I plug 0 right here, it's a positive 5. Positive 5 raised to that power, then third root is still a positive number. What's a negative divided by a positive number? Negative. Which interval are we concaved up, Stews? Anything less than negative 5. And that's your answer.